Hello students, welcome to Eshwari Thaniksha channel. In this video, we are going to study one of the important topic, that is power of the lens. So before starting the video, students, if you are new to our channel, subscribe our channel and also share this video with your friends. So now let us start the video. Power of the lens is represented by capital P. So here important question what can be asked is define power. So you have to write it is defined as the reciprocal of a focal length. And formula you will be writing P is equal to 1 by F, where P is called as power of the lens and F is called as the focal length. And then SI unit of power is given by diopter. So very important, make a note of this. So this can be asked in the examination, diopter, and it is represented by capital D. And one more thing important you have to remember is focal length should always be taken in meter. So if it is given in centimeter in the question, convert to meter. So focal length should be taken in meter. And then define one diopter. So even this can be asked in the examination. Definition for one diopter. So you can write one diopter is the power of the lens whose focal length is 1 meter. If the focal length is taken as 1 meter, then it is called as 1 diopter. So what is exactly this power of the lens? So let us try to understand. So take these two examples. So in the first example, so this is what type of lens is this? So this is convex lens. So both I have taken the convex lens. So pass the rays. In the first example we can see when we pass the rays, it is going to bend and it is going to meet at a point. So this is the principal focus. So here you can see the bending is not so much. So here you can see the angle is very small. So meaning is this convex lens bends this light rays only to small extent. So whereas here you see this convex lens, it is bending this light rays to with greater angle. See here so much of bending is there, and see the angle here, angle is very much bigger. So now here we can say that here the power of the lens, in the first case the power of the lens is less. So power of lens is less. So that is why you can see bending is less. So bending is less here. Whereas second, the bending is more. So if bending is more, meaning is power of the lens is more. So you can write here. In the second case, power of the lens is more. Power of lens is more. Now compare the focal length. So from this, that is O, optical center, from optical center to the principal focus. So this length we call it as focal length. So here I have written, see, this is the focal length in the first case. In second case you see from here to here, this distance is called as focal length. Where the focal length is more, so here the focal length is more. When power of the lens is less, focal length will be more. So they are reciprocal to each other. So here we have written power of the lens is inversely proportional to focal length. So the meaning of this is when power increases, focal length will decrease. That is the meaning. So here you can see power, if it is, so here you can see power is less. If power is less, then focal length is more. So in this case, in the first case, so in the first case we can write power is less, focal length is more. So they are inversely proportional to each other. Inversely proportional meaning is when one decreases, another will increase. So here you can see focal length is more, power is less. So in the second case you see power is more, focal length is less. So here you can write power is more, focal length is less. So this is the relationship. They are inversely proportional to each other. And one more important point what you have to remember here is If power value is given as positive, then it is a convex lens. Sign you should see. If it is convex lens, power will be positive. If it is concave lens, power will be negative. So let us take this example to understand. So here two examples are given. Find focal length and the type of lens. So let us find now first the type of lens. So here you can see positive value. Positive value means you know that power is having positive value, meaning it is a convex lens. So convex lens. And second one, power if it is negative, then it is concave lens. Concave lens. So this is power and here it is given positive. So see here, if it is positive, then it is convex lens. If it is negative, then it is concave lens. Next we will find focal length. So for the first one, P is equal to 1 by F. Power is given as plus 2 is equal to 1 by F. So therefore F is equal to 1 divided by, so this is positive value, 1 divided by 2. So 1 divided by 2 is nothing but 0.5. Focal length is in meters. So 0.5 meter. So here in the first case, focal length is 0.5 meter. So let us see for the second example. So second one, power is equal to 1 by F. So power is given as minus 2.5 is equal to 1 by F. Therefore F is equal to 1 divided by minus 2.5. So this is nothing but 10 by 25, negative sign. 5 2s are 10, 5 5s are 25. So this is equal to minus 2 by 5. So divide this further. So 5 and 2. So 0.0, 5 4s are, you will be getting 20. 0.4 and there is a negative sign. So in the second case it is minus 0.4. So here you can write in the second case focal length is equal to minus 0.4 meter. So is that clear? So this is how we find the focal length and also the type of the lens. So to find the type of the lens, see the sign. And to calculate the focal length, you have to use this formula. So is that clear, students? If you have any other doubt, you can write in the comment section. I'll meet you in the next video, students.